In this lesson, we're going to look at molar concentration and how we can determine the molar concentration of a solution and also use the concentration in other types of problems. So the molar concentration of a solution is the number of moles of solute per volume of solution. So we can write that in an equation. Molar concentration equals the amount of solute, which we use in moles, over the volume of solution, which we need to have in liters. Okay, and notice that is the amount of solute, so that's the thing that's dissolved in the solvent. But it's not the volume of solvent, it's the total volume of solution. And so we can also shorten that to a uppercase C equals a lowercase n over an uppercase V. So C equals n over V is our formula for calculating molar concentration. And the units for molar concentration are moles per liter. So let's look at a sample problem on how we can use this equation. A student dissolves 0.212 moles of iron 3 chloride to make 175 milliliters of solution. Find the molar concentration of the solution. So let's pick the information out of the question. So we have 0.212 moles, and we have 175 milliliters, which is the volume, and we're asked to find the concentration. So N is 0.212 moles, V is 175 milliliters, and we're trying to find the C. So before we put the numbers into the equation, we need to check the units. Right? So we always want our units to be moles and liters. Well, right now, those are not the units we have. We have the moles, but we've got milliliters instead of liters. So we need to convert that volume in milliliters into liters. And we know there's 1,000 milliliters in 1 liter, so we can use this conversion factor and divide by 1,000 to get 0.175 liters. Now that we have moles and liters, we can go ahead and calculate the concentration using the formula of N over V, 0.212 moles over 0.175 liters, which gives us an answer of 1.21 moles per liter. So that is the molar concentration of the solution that the student created. So let's look at another sample. A saline solution contains 0.90 grams of sodium chloride, NaCl, dissolved in 120 milliliters of solution. What is the molar concentration of the solution? So we've got 0.90 grams, so that is a mass, and we have 120 milliliters of volume, and we're asked to find the concentration. So when we calculate the concentration, remember we need moles and volume, not mass. But we don't have a scale that can measure out moles. We always need to measure things in mass. So this is how solutions are made more commonly, is by determining the mass. So when we check the units, we realize we don't have either of the correct units. So we have to convert the volumes to liters, and we also need to convert that mass to moles. So in converting the volume to liters, we divide by 1,000, so we get 0.12 liters. Now hopefully you remember how to convert from mass to moles, right? We're going to use the molar mass of sodium chloride as a conversion factor. So we're going to divide by 58.44 grams, the molar mass of NaCl, and we get that the number of moles in 0.90 grams is 0.0154. So remember, this isn't your final answer, so you don't want to round too much, and when you do round, you want to make sure that you're rounding correctly. Now we can calculate the concentration. So we take the moles, 0.0154, divide by the liters, 0.12, and we get a final answer of 0.13 moles per liter as the molar concentration of that sodium chloride solution. We can also use this formula, C equals N over V, to solve for other unknowns. So let's look at another sample problem. A saturated solution of calcium sulfate, CaSO4, has a concentration of 0.0153 moles per liter. A student takes 65 milliliters of this solution and evaporates it, so removes all of the solvent, all of the water. What mass in grams is left in the evaporating dish? So we'll find the information in the question. We've got a concentration of 0.0153 moles per liter and a volume of 65 milliliters, and we're being asked to find the mass. So the volume in the question is in milliliters, so we always have to make sure we convert that to liters, right? So we divide by 1,000, we get 0.065 liters. Now we're going to use the concentration equation to find moles, and then once we have moles, we can then find our mass. So the formula C equals N over V can be rearranged to find moles, and so that rearranges to N equals C times V. So 0.0153 moles per liter times 0.065 liters gives us our number of moles of 9.945 times 10 to the negative 4 moles. Now that we have the moles, we can find the mass using the molar mass of calcium sulfate, which is 136.15 grams. So in our conversion factor, we put the molar mass over 1 mole. The moles cancel, and we get a final answer of 0.14 grams left in the evaporating dish. You can also use the molar concentration as a conversion factor. So rather than having to do the separate calculations and steps, you can do what we have been doing, which is stringing the conversion factors in a line to get from what we're given to what we want. So let's look at another example and use that method. So a solution of glucose, C6H12O6, has a concentration of 0.250 moles per liter. So that concentration means that 1 liter equals 0.250 moles for that solution. So we can use that as a conversion factor. So what is the volume in milliliters of a sample of solution that contains 15.0 grams of glucose? So the information in the question, we've got this mass of 15 grams, and we've got a concentration of 0.250 moles per liter. We need to find a volume in milliliters. So, like the other problems we had done, you want to start with the number given in the question. In this case, there is more than one number given in the question. So the one you're going to start with is the mass. You're not going to start with the concentration because that's one of your conversion factors. So you're going to start with the mass, 15.0 grams. Then you're going to convert that to moles using the molar mass of glucose, which is 180.18 grams. So we've divided by 180.18. We now have the number of moles. We're trying to find the volume. So the next step is we're going to convert to liters using that molar concentration. So because we're trying to get rid of moles, the 0.250 moles will go on the bottom of the conversion factor over 1 liter. So the moles are going to cancel, and now we're at liters. The question is asked for the volume in milliliters, so we have one more conversion factor we need to add on. 1,000 milliliters per 1 liter, so we're multiplying by 1,000, and when you put all that into your calculator, you get an answer of 333 milliliters. So for this solution of glucose, if you had 333 milliliters of the solution, it would contain 15.0 grams of glucose. So those are the types of problems that you can solve using molar concentration, either using the formula C equals N over V, or using the concentration as a conversion factor within a string of conversion factors.